Hello students, this is the third class on moving charges and magnetism. In our last class, we were discussing the magnetic force on a moving charge. Its expression is Fm equal to QVB sin theta. After that, we were discussing the magnetic force on a current carrying conductor which is in presence of the magnetic field. Is it? Okay. And we got the idea about the magnetic force and the direction of magnetic force, so which can be easily determined by using the Fleming's left hand rule. So we should stretch our fingers, forefinger, middle finger and the thumb perpendicular to each other. The magnetic field indicates, the forefinger indicates magnetic field, middle finger indicates the direction of motion of charge, or you can say the current, because current is the motion of the charge particle, and the thumb indicates the direction of magnetic force. Okay, so today we discuss motion of charge particle. Motion of charge particles in uniform magnetic field. Uniform magnetic field. Okay, so we'll study this concept under three headlines. So, if a charge particle is moving in presence of magnetic field, so then the question arises: in what direction it is moving? In what orientation it enters the magnetic field? So it may move with 0 degree, 10 degree, 20 degree, 40, 50, 90, 180, like this. Okay, so on the basis of that orientation, or on the basis of direction of the entry of that charge particle in presence of in the magnetic field. So on the basis of that, we have divided this concept into three classes. Okay, cases. So case number one, when the charge particle move with the angle 0 degree or 180 degree with the magnetic field. Suppose that charge particle is moving with the 0 degree or 180 degree with the magnetic field. So I say, so this is the region of magnetic field. And say, if I draw the parallel lines, you should understand this is uniform magnetic field. Is it? Okay. Now the charge particle enter the region. Okay. For example, this is the region of uniform magnetic field, and say our charge enters the region of uniform magnetic field. Okay. So what's the formula? Our formula is Fm is equal to QVB sin theta. What's the theta? Theta is angle between V vector and B vector. Okay, and see this diagram. So this is moving with velocity v. What's the angle between v and b now? This is 0 degree. This is 0 degree. If it is 0 degree, sine of 0 is 0. If sine of 0 is 0 means Fm is 0. Means magnetic force on that charge particle is 0. Suppose the charge particle is moving like this. The charge particle is moving with velocity v in the magnetic field in this direction. What's the angle between b and b? B in this direction positive x, v is negative x. So the angle between these two is 180 degree. So here the theta, in the second case, theta equal to 180 degree. If theta equal to 180, sine of 180 is 0. If sine of the value of sine function is 0, then the entire term is 0. Is it clear? Okay. So you may get a question: what's the trajectory of a charge particle which is moving in a uniform magnetic field with an angle 0 degree or 180 degree? What's the answer? Charge particle uniform magnetic field daga 0 degree ನಲ್ಲಿ ಮೂವ್ ಆಗ್ಲಾತಿತ್ತು ಅಥವಾ 180 degree ಮೂವ್ ಆಗ್ಲಾತಿತ್ತು. 0 degree 180 degree ಅನ್ನೋ ಬದಲು ನಾವು ವರ್ಡ್ ಯೂಸ್ ಮಾಡ್ಬೋದಾ? Suppose the charge is moving parallelly or anti-parallelly with the uniform magnetic field. Parallel ಆಗಿ ಅಂದ್ರೆ 0 degree, anti-parallel ಅಂದ್ರೆ 180 degree. ಹಿಂಗೆ magnetic field ಮೂವ್ ಆಗ್ಲಾತಿರ್ತದೆ. ಅದು ಟ್ರಾಜೆಕ್ಟರಿ ಏನಿರ್ತದ? ಟ್ರಾಜೆಕ್ಟರಿ ಅಂದ್ರೆ ಏನು? So it is the path of that moving body. So what's the path of that moving body? So it is straight line. It is a linear motion. It covers linear motion. Follow the straight line path. Why it is following the straight line path? Because it is not experiencing any magnetic force. What is the significance of magnetic force for him? What is the significance of magnetic force? So in question mark answer madbeka. The magnetic force changes the direction of motion of charged particle. So this is the significance of magnetic force on the charged particle. Okay, a magnetic force ಏನು ಕೆಲಸ ಮಾಡ್ತದೆ ಇಲ್ಲಿ ಏನು ಇಂಪಾರ್ಟೆನ್ಸ್ ಅದನ್ನು it will not alter its velocity, sorry, it will not alter the speed of the charged particle. I mean it will not alter the magnitude of velocity, so which is constant or same, but it changes the direction of the motion. So we can say it changes the direction of velocity. Is it clear? So that's why here there is no direction, there is no change in the direction because of the magnetic force is zero. So it is following its original path. ಯಾವ path ಬಂದಿರ್ತದ magnetic field ಒಳಗ ಅದೇ path ಇಂದ ಕಂಟಿನ್ಯೂ ಆಗಿ ಹೋಗ್ಬಿಡ್ತದ. So this is the first case. Okay, next case. When charged particles move with angle 90 degree, with angle 90 degree, it means the charged particle moving in a uniform magnetic field perpendicularly. So it is moving perpendicular to the uniform magnetic field. Okay, so if I want to represent the uniform magnetic field perpendicular to the plane, okay, so I'll draw like this, right? So what's the direction of magnetic field now? What the direction of magnetic field? So it indicates is the uniform magnetic field perpendicular to the plane directing inwards. Okay, so this is the case, and a charged particle enters a region of magnetic field at an angle 90 degree. Is it correct? So the velocity of that charged particle is like this, and the magnetic field is inward. The angle between these two is 90 degree. Okay, so when it enters the magnetic field at an angle 90 degree, can it experience magnetic force or not? Can it experience magnetic force or not? Yes, it has to experience how much magnetic force it may experience. So as per the formula, Fm is equal to QVB sin of angle 90 degree. What's the value of sin 90? This is 1. So this is QVB. So we can say this is the maximum magnetic force of that charged particle with that velocity in that magnetic field. So among all the orientations, like a 10 degree, 20 degrees, compare ಮಾಡಿದ್ರೆ 90 degree ನಲ್ಲಿ maximum force ಅದ experience ಮಾಡ್ತಿರ್ತದ ಯಾವುದು ಆ moving charge particle. Right? So here it is experiencing the force. Next question is this: in what direction it may experience? In what direction it may experience? ಯಾವ ಡೈರೆಕ್ಷನ್ ಆಗ್ಬೋದು? ಹೆಂಗ್ ನೋಡೋದು ಇವಾಗಿಂದ? ಹೆಂಗ್ ನೋಡಬಹುದು? By using Fleming's left hand rule. Okay? So stretch your fingers. Forefinger indicating magnetic field. Say magnetic field. What are the direction of the charged particle? It is in this direction, x direction, and see my middle finger. Okay, so then the magnetic force, it is upward direction. Howdala? Okay, so in the charged particle ಗೆ upward motion ಆಯಿತು. As a result of that, so it has to it try to move in upward direction like this. Is it right? Why it is moving upward? Because the magnetic force is changing this direction. Next, so once it start to move in upward direction, again it experiences the magnetic force. So say in case in about magnetic force, this is the magnetic field, and see my middle finger. So it is upward direction like this. Now what about the force? It is in this direction, negative x direction, as per this coordination. Okay, so in negative x that bandile. Hangare charge particle it start to pull towards this direction. Okay, so then the charge particle actually want to move like this. It wanted to move in this direction, but because of that magnetic force, it is pulled in this direction. Okay, consider that, right? So this direction adu ಬರ್ಲಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತು ಹೆಂಗೆ ನೋಡಿ ಇವಾಗ. Okay, suppose ಇಲ್ಲಿ ಏನು ಇರಲಿಲ್ಲ, it wanted to it is trying to move in this direction, but because of magnetic force, again the force of the direction of force changed. Yeah, direction of force change ಆಯ್ತು because the direction of the velocity is changed. Direction of motion is changed. Here the direction of motion was like this, so that's why upward. So here the direction motion is like this, so that's why the force in this direction. Here the direction of motion is like this, the force is magnetic force, and what about the charged particle? Direction of charged particle like this. See my finger, it is towards me. And what about the force? See the thumb, it is inward direction. ಸೊ ಫಸ್ಟ್ ಈ ಡೈರೆಕ್ಷನ್ ಫೋರ್ಸ್ ಬಂತು, ಆಮೇಲೆ ಈ ಡೈರೆಕ್ಷನ್ ಫೋರ್ಸ್ ಬಂತು. ಇವಾಗ ಏನಾಗ್ತದ, ಈ ಡೈರೆಕ್ಷನ್ ಫೋರ್ಸ್ ಬದಲಾಗ್ತದ. ಆಸ್ ಅ ರಿಸಲ್ಟ್ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಮೂವಿಂಗ್ ಇನ್ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಇಟ್ ಟ್ರೈ ಟು ಮೂವ್ ಡೌನ್ವರ್ಡ್. ಓಕೆ, ಸೊ ಡೌನ್ವರ್ಡ್ ಬಂದ್ಮೇಲೆ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಇಲ್ಲಿ ಡೌನ್ವರ್ಡ್ ಬಂತಪ್ಪ ಅಂದ್ಕೊಳ್ರಿ ಇವಾಗ. ಸೊ ಇಲ್ಲದ, ಸೊ ಇವಾಗ ಮತ್ತೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, ಸೀದಾ ಮಿಡಲ್ ಫಿಂಗರ್, motion of charge particle downward, and what about the force? X direction. So this is x. X ಇರೋದ್ರಿಂದ ಹಿಂಗೆ ಹೋಗ್ಬೇಕಾಗಿ ಪಾರ್ಟಿಕಲ್ ಆಯ್ತಾ, ಮತ್ತೆ ಆ ಕಡೆ ಹೋಗ್ಲಾಕ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾ ಹಿಂಗೆ, ರೈಟ್? ಮತ್ತೇನಾಯ್ತಾ ಅಗೇನ್ ಇಟ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್ ಹಿಂಗೆ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ದ ಟ್ರಾಜೆಕ್ಟರಿ ಆಫ್ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್. This is the trajectory of charge particle moving perpendicular to the uniform magnetic field. ಗೊತ್ತಾಗ್ತದಾ? ಓಕೆ, ಸೊ you may get one more question. So what's the trajectory of charge particle which is moving perpendicular to the magnetic field? So our answer must be circular path. You should answer it is circular path. Is it clear? Okay, how much force is experiencing that moving charge particle here? So it is experiencing QVB value. So you may substitute the value of Q like 2 coulomb, 3 coulomb. You can substitute the value of velocity like 10 meter per second, 20 meter per second, and you may substitute the value of magnetic field, which is in terms of Tesla. Is it clear? So if you calculate it, you will get a number. So that is the value of the force experienced by the charge particle. Okay, next one more question. The magnetic force, I say this is A point, this is B point, this is C position, this is D position. The magnetic force at these points, the magnetic force on the charge particle at the point A, B, C, D are the same or different? Are they same or different? So if I ask like this, so the question is only incomplete. Okay, so I should say like the vector forces are they same or not? Or should I say the magnitude of forces are the same or not? Okay, so if I say the magnetic force at A point, magnetic force at B point, magnetic force at C point, magnetic force at D point, so they are different. They are different. Okay, if I say the magnitude of magnetic force at all the points, it is same. Magnitude of magnetic force just relates QVB, QVB. But why the vector of vector forces are changing? Because the direction is changing. So here the direction is in this direction. Okay, ಇಲ್ಲಿ ಈ ಕಡೆ horizontal, ಇಲ್ಲಿ ಮತ್ತೆ vertical, ಇಲ್ಲಿ ಮತ್ತೆ horizontal. So at all the point the direction of influencing force is changing, but the magnitude of that influencing force ಯಾವುದು ಇನ್ಫ್ಲುಯೆನ್ಸ್ ಮಾಡ್ತಾ ಇರೋದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್, ಬಟ್ ಅದು magnitude ಏನದ ಎಲ್ಲ ಪಾಯಿಂಟ್ದಲ್ಲೂ ಸೇಮ್ ಅದ. ಕ್ಲಿಯರ್ ಆಗಲಾಗತ್ತದ? ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ಈಗ ನಿಮ್ಗೆ ಎಕ್ಸಾಮ್ ಪರ್ಪಸ್ ಆಗಲಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಪರ್ಪಸ್ ಆಗಲಿ ಹಿಂಗೆ ಕ್ವಶನ್ ಬಂತಂದ್ರೆ, whenever a charge particle moving with a particular velocity enter region of magnetic field B, what is radius? What is this radius? Okay, ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗ್ತದ. ಆಮೇಲೆ ನಿಮಗೆ ಎಷ್ಟು ಟೈಮ್ ತಗೋತದ ಟು ಕವರ್ ಒನ್ ಸೈಕಲ್, which is not a time period. And you may get a question like, what's the frequency of the charge particle moving in uniform magnetic field? So if you want to answer such a questions, you need to derive the expression for the time period, frequency as well as the radius. Is it? Okay, let us check. If I'm equal to QB, so we got one Q. And see this diagram. The charge particle is moving in a circular path. Is it clear? So it is circular path. Right? And we know the basic concept. Whenever a charge particle is in a circular path, it must need a force. What is that force? Needed force? That is centripetal force. Is it? ಯಾವುದೋ ಬಾಡಿ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಅಲ್ಲಿ ಹೋಗಬೇಕಂದ್ರೆ ಅದಕ್ಕಲ್ಲಿ ಏನಿರಬೇಕು, ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ಇರಬೇಕು. ದಟ್ ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ಇಸ್ ರೆಸ್ಪಾನ್ಸಿಬಲ್ ಟು ರೆಸ್ಟ್ರಿಕ್ಟ್ ದಟ್ ಬಾಡಿ ಇನ್ ಅ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್, Is it? ಹಂಗಾದ್ರೆ ಈ ಮೂವಿಂಗ್ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಅಲ್ಲದಂದ್ರೆ ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್. ಬಿಕಾಸ್ ಆಫ್ ದ ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ಇಸ್ ಕವರಿಂಗ್ ದ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್. Is it? And see the direction of the centripetal force is always directing towards the center. And see this point, is there force or not? Yes, it is directing towards center. It is the force directing towards center. The force directing towards center. Is it clear? So what type of force is experiencing? Which force is acting towards the center? Actually, magnetic force is acting towards the center of that circular path. Now I can say the magnetic force experienced by the charged particle itself providing centripetal force to the charged particle to be in a circular path. Allen charged particle ಮೇಲೆ ಪ್ರತಿಯೊಂದು ಪಾಯಿಂಟ್ ನಲ್ಲೂ ಆಕ್ಟ್ ಆಗ್ತಾ ಇರುವಂತ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್ ತಾನೇ ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ತರ ಆಕ್ಟ್ ಮಾಡ್ಲಾಕ ಹೋಗ್ತದ. ಆ ಸೆಂಟ್ರಿಪಿಟಲ್ ಫೋರ್ಸ್ ಅನ್ನು ಆಕ್ಟ್ ಮಾಡೋದ್ರಿಂದ ಆ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಅನ್ನು ಕವರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತದ. ಹೌದಲ್ಲ? ಓಕೆ, ನಾವು ಹೆಂಗ್ ಗೊತ್ತಾಯ್ತು ಈಗ? ಇನ್ ಡೈರೆಕ್ಟ್ಲಿ ಟುವರ್ಡ್ಸ್ ಸೆಂಟರ್ ಅದ. ಸೊ ನೌ ಐ ಕ್ಯಾನ್ ಸೇ the magnetic force provides the necessary centripetal force, to the moving charge, if so then I can write an equation. So that is the magnetic force is equal to Fc. ಏನಿರಬಹುದು Fc ಅಂದ್ರೆ it is centripetal force. What's the formula for magnetic force? So this is QVB. Okay, and what about the centripetal force? Centripetal force formula ಏನು? m into velocity square divided by radius. Is it? Next, so here it is V and this is square of V, right? So here the term is QV and here 1V cancels, so remaining 1V divided by R. What I want now? So I want the radius of that charged particle which is moving with the mass, so which is moving with the velocity V in our uniform magnetic field B. So three answer terms are equal to mv divided by qb. It's a very important result. ಏನು ಗೊತ್ತಾಯ್ತು ನಮಗೆ? ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಎಷ್ಟು ವೆಲಾಸಿಟಿಯಿಂದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈಕ್ 10 ಟೆಸ್ಲಾ 20 ಟೆಸ್ಲಾ ಅದರೊಳಗೆ ಎಷ್ಟು ವೆಲಾಸಿಟಿಯಿಂದ ಹೋಯ್ತು ಅಂದ್ರೆ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ಗೆ ಒಂದು ಹೋಗ್ತದ. ಯಾಕಂದ್ರೆ 90 ಡಿಗ್ರಿ ಹೊಂದಲ್ಲ ಅಂತ ಹೇಳಿದ್ವಿ. ಹಂಗಾರೆ ಎಷ್ಟು ರೇಡಿಯಸ್ ದಾಗ ಸುತ್ತಾಗ್ಲಾತದ. ಸೊ ವಿ ಕ್ಯಾನ್ ಗೆಟ್ ಇಟ್ಸ್ ರೇಡಿಯಸ್. Okay, it's a one important result. Is it? Next question. Is it a periodic motion or not? So once allow the charged particle to enter the uniform magnetic field with the 90 degree, it starts to repeat its motion in the circular path. And then question rises, how much time it takes to complete one rotation? So which is called the time period. So what you calculate now here? So here it is radius of charged particle, and here it is time period. What's the formula for time period? If you know the distance traveled and the velocity of charged particle, you can easily get the time period. Is it? So actual formula is speed is equal to or velocity is equal to distance divided by time. So now I'll take the time t this side, left hand side, and here this become distance divided by speed. Is it right? How much distance it has to cover? It has to cover one complete circle. ಸುತ್ತಾಗಬೇಕಂದ್ರೆ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಮಾಡಬೇಕಲ್ಲ? It is a circumference of that circle. ಇಲ್ಲಿ ಹೋಗ್ಬಿಟ್ಟು ವಾಪಸ್ ಇಲ್ಲಿಗೆ ಬರಬೇಕಂದ್ರೆ ಒಂದು ಕಂಪ್ಲೀಟ್ ಸರ್ಕಲ್ ಅನ್ನ ಕವರ್ ಮಾಡಬೇಕು, which is nothing but circumference. ವೃತ್ತದ ಸುತ್ತಳತೆ ಅಂತ ಕಲ್ತಿರ್ತೀವಿ, ಹೌದಾ? ಸೊ ಎಷ್ಟಿದೆ ಡಿಸ್ಟೆನ್ಸ್? It has to cover a distance of 2 pi r. The distance is 2 pi r. With what speed it is moving? The speed is same at all the points because speed is the magnitude of velocity here. Okay, I'll write the v as it is. Right? See the next step. 2 pi divided by v. So what the last term here? R. Here it is r. Right? So instead of r, I can write this term. Okay? So substitute the value of r. So this is mv divided by qv. And this v cancel. Okay, so final equation t is equal to 2 pi m divided by qb. So this is the time period of that charged particle in that uniform magnetic field. If you know the time period, it is very easy to calculate the frequency. Okay, how to calculate the frequency? There's a simple formula. F is equal to 1 by t, reciprocal of the time period. So F is equal to 2 pi m by qb. So F on ulta reciprocal. So this is qb divided by 2 pi m. This is the frequency. And I made one more question. What's the angular frequency? What is the angular frequency? Okay, so what's the angular frequency? Angular frequency formula will be W is equal to 2 pi f. 2 pi f. 2 pi as it is. We know the f value. This is qb divided by 2 pi m. Now 2 pi cancel. So omega is equal to qb divided by m. Okay, so these are very important results for the study of motion of charged particle. So one angle is 90 degree. Is it? Okay, so these are our results. Radius of that moving charge, time period, frequency and angular frequency. Is it? Okay, now I'll ask some questions. Now the charged particle enters this region like this. What's the angle now? 90 degree. Okay, so in the first case its velocity is 10 meter per second. 10 meter per second. Okay, so in actually when it enters region of uniform magnetic field, it covers the circular path. And we observe it is like this. And I measured its radius r1. Okay, so we give a number. So I said this is 100 meter. So just we convince something 100 meter okay. So next I change its velocity. So 20 meter per second. Okay, so here the time period is t and the frequency is f, angular frequency is omega. When velocity is v1 like a 10 meter per second, I doubled its velocity. Now my question is, what's the time period? See the equations. What's your answer? Or what's the frequency? If I double the velocity, what about the time period of that moving charge, and what about the frequency of moving charge? If you observe this equation, you can answer, sir, that velocity is independent of the time period, the time period is independent of velocity. Frequency is independent of velocity. ನೀವು velocity ಹೆಚ್ಚಿಟ್ಟು ಎಷ್ಟಾಗಿ ಮಾಡ್ಕೊಳ್ಳಿ, velocity magnitude ಎಷ್ಟಾಗಿ ಮಾಡ್ಕೊಳ್ಳಿ, ಇಲ್ಲಿ ಮಾತ್ರ ಈ ವ್ಯಾಲ್ಯೂಸ್ ಚೇಂಜ್ ಆಗಂಗೆ ಇಲ್ಲ. ಹೌದಲ್ಲ? ಸೊ ಯಾಕೆ ಮ್ಯಾಥಮೆಟಿಕಲಿ ಹೇಳ್ಬೋದು ಸರ್ there is no velocity term in the time period expression and frequency expression, so that's why time period is not related to or it's not depending on the velocity. But how to conclude this one? I'll explain. Saying so when I allow the charged particle to move with a 10 meter per second, it covers 100 meter. So if you observe this equation, you can understand how the r related to, and see here r equal to mv by qv. Was the m? Mass of the moving charge. Motion takku mass change agtade endrile illa. What is the q? Charge on the moving body. Charge value of charge like 10 coulomb, 20 coulomb like this. So rest idaga 10 with charge ಮೇಲೆ move ಆಗಬೇಕಾದ್ರೆ 20 30 ಆಗ್ತದೆ ಅಂತ ಹೇಳಲಿಕ್ಕೆ ಆಗ್ತದೆ no. So which is constant? M is constant, Q is constant, and are you changing the magnetic field? No, I am maintaining a constant magnetic field. So M constant, Q constant, B constant. Okay, so this is variable. Once I may allow it to move with the 10, next I may allow it to move with the 20, 30 like this. So I can change the value of velocity. As I change the value of velocity, what happens? The radius changes. So I can write that R changes. R is directly proportional to V. Is it? So if I double the velocity, what are the radius? Radius doubles. If I triple the velocity, what are the radius? It triples. ಹೌದಲ್ಲ? ಸೊ ಹಂಗಾರೆ ಏನಾಯ್ತಾ? ಸೊ ನಾವು ರೇಡಿಯಸ್ ಹೆಚ್ಚಿಗೆ ಸ್ಪೀಡ್ ಹೆಚ್ಚಿಗೆ ಮಾಡಿದ್ರೆ ರೇಡಿಯಸ್ ಹೆಚ್ಚಾಗ್ತದ. ಸೊ ಗೊತ್ತಾಯ್ತಾ? ಸೊ ದಿಸ್ ಡಿಸ್ಟೆನ್ಸ್ ಡಿವೈಡ್ ಬೈ ಟೈಮ್. ಸೊ ಡಿಸ್ಟೆನ್ಸ್ ಡಿವೈಡ್ ಬೈ ಸ್ಪೀಡ್, ಟೈಮ್ ಪೀರಿಯಡ್ ಈಕ್ವಲ್ ಟು. ಹೌದಾ? ಸೊ ನಾವು ಏನಾದರೂ ಆರ್ ವ್ಯಾಲ್ಯೂ ನಾವು ಜಾಸ್ತಿ ಮಾಡ್ಕೊತ ಹೋದಿವಿ ಅಂದರೆ ಅಥವಾ ವಿ ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಮಾಡ್ಕೊತ ಹೋದ್ರೆ ಆರ್ ಜಾಸ್ತಿ ಆಗ್ತದ. If you double this, it doubles. If you triple this, it triple. If you take 4 times of V, it becomes 4 times of radius. ಇವಾಗ 20 meter per second ಥ್ರೋ ಮಾಡಿದ ನಾನು ಅವಾಗ ಏನಾಯ್ತಾ? The charge particle moves like this. What happened? Its radius increases. ಎಷ್ಟು increase ಆಯ್ತು? velocity ಎಷ್ಟು time ಜಾಸ್ತಿ ಆಯ್ತು, radius ಅಷ್ಟು time ಜಾಸ್ತಿ ಆಗ್ತದ. Right. So what are the time period? Time taken to complete one rotation. Smaller path, smaller velocity. Smaller path, we have a smaller velocity. Larger path with a large velocity. larger value divided by larger value, smaller value divided by smaller value. So the ratio or the value is always constant. So the time period is same because R is directly proportional to V. As you change the V, R changes. As you increase the velocity, the R increases. As you increase the speed or magnitude of velocity, the distance traveled increases. Okay, less distance with a less speed, large distance with a large speed. So that the time period will be always same. If the time period is same, the frequency is same. If the frequency is same, the angular frequency is also same. Okay, so you must be able to answer such a tricky questions. Okay, next one. Case number 3. When charge particle move with the angles other than 0 degree, 90 degree, 180 degree. You know what happens when it is moving with 90 degree? It follows circular path. You know what happens when the charge is moving with 0 or 180? It follows the straight line. Okay, so now it is other than these angles like 40 degree, 50 degree, 120 degree, like this. So with that, with the magnetic field, so here it is moving with the 30 degree now. It is moving with 30 degree. So velocity here, magnetic field here. So the angle between these two is 30 degree. So what happens in this case? Right? So now we resolve this velocity vector into two components. So here this become Vx and this become Vy. So what's the value for Vx? We can write it as V cos theta. Hang marbodu if I draw a right angle triangle. Okay, so this become opposite side. This is hypotenuse. This is adjacent. Okay, so cos theta is equal to adjacent side divided by hypotenuse. So what's adjacent? This is adjacent side divided by hypotenuse. Hypotenuse value you know V. Adjacent value you know we know it is Vx. So we don't know it is Vx. Vx divided by V. Okay, then Vx equal to take this V here. This become V cos theta. Here, okay. Similarly, I draw one more line here. So if this is theta, this is also theta. If this is theta, this is opposite side, and this is hypotenuse side. So hypotenuse value both it is capital V. I want the opposite side value. So I have to go back now. Sin theta is equal to opposite divided by hypotenuse side. Opposite value is this is Vy. Hypotenuse value this is. So this is V, total V. So Vy is equal to V into sin theta. Okay, so I can write it. This are Vx equal to V cos theta, Vy is equal to V sin theta. Right? So here, this is the direction of velocity V. This is vector, and this is Vy is equal to its value is V sin theta. Its value V cos theta. Okay. Right. So V is resolved into two components. Okay. Let us consider the y component. Of velocity. It means this component is perpendicular to the magnetic field. The Vy is perpendicular to the magnetic field. ಹಂಗಾದ್ರೆ ನಾವು ಸಪರೇಟ್ ಆಗಿ ಏನು ಚೆಕ್ ಮಾಡೋದಂದ್ರೆ Vy ಕಾಂಪೋನೆಂಟ್ ಎಷ್ಟು ಫೋರ್ಸ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡ್ಲಾತೈತಿ, Vx ಕಾಂಪೋನೆಂಟ್ ದಿಂದ ಆ ಚಾರ್ಜ್ ಗೆ ಎಷ್ಟು ಫೋರ್ಸ್ ಬರ್ಲಾತೈತಿ. ಹೌದಲ್ಲ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್ ಇರಬೇಕಂದ್ರೆ ವೆಲಾಸಿಟಿ ಇರಬೇಕು. ದ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಮಸ್ಟ್ ಮೂವ್ ಇನ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, ದೆನ್ ಇಟ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್. ಹಂಗಾದ್ರೆ ಈ ವೆಲಾಸಿಟಿ ಇಂದ ಎಷ್ಟು, ಈ ವೆಲಾಸಿಟಿ ಇಂದ ಎಷ್ಟು ತಿಳ್ಕೊಂಡ್ರೆ. ಓಕೆ, ಲೆಟ್ ಅಸ್ ಸೀ ಬೈ ದ Vx ಕಾಂಪೋನೆಂಟ್. ಸೊ ಬೈ ದ Vx ಕಾಂಪೋನೆಂಟ್ V cos theta, and see the magnetic field V and Vx both are in same direction. ಯಾವ ಡೈರೆಕ್ಷನ್ ದಾಗ ಎರಡು ಇದ ಡೈರೆಕ್ಷನ್ ದಾಗ ಹಾರಿಜಾಂಟಲ್ ಡೈರೆಕ್ಷನ್ ದಾಗ ಎರಡು ಇದಾವ. ಹೌದಾ? ಸೊ ಹಂಗಾದ್ರೆ ಇವಾಗ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್ ಎಷ್ಟು ಆಗ್ತದ? ಸೊ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ಡ್ ಬೈ ದಟ್ ಮೂವಿಂಗ್ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್. ಸೊ ದಟ್ ವಿಲ್ ಬಿ Q will be and the sign of angle. So instead of V, I'll take this is x component. That is Vx. Okay, V into sign of angle. What right here? Both are in the same direction, so the angle is 0 degree. Right? So Fm is equal to 0. Why? So the magnetic force by the x component of the velocity is 0. Okay, and there is one more component of that velocity. What is that? That is Vy. Okay, so Vy. So what's the effect of Vy? Okay, Vy is equal to V sin theta. Right? So magnetic field is like this, and where is the Vy? Vy is in this direction. Is it? So the angle between these two is 90 degree. Angle between these two is 90 degree. So I'll write this is Fy. So this one I check this as Fx. So why I am writing it as Fx? The force due to the x component of velocity, and force due to the y component velocity. This is Q into Vy into B into sine of angle. Angle between Vy and B. This is 90 degree. Clear? Okay. So next. So sine of 90 is 1. So Q into Vy into B. This is Fy. Clear? So I can substitute the value of V1, Vy value in 3. Vy value no V sin theta. This is Vy value. ಇಲ್ಲೇನಿತ್ತು sin of 90 ನು Vy ಮತ್ತೆ B ದ ನಡುವಿನ angle sin theta ಬರ್ನ. ಇವಾಗ ಇದನ್ನ ಎಕ್ಸ್ಪಾಂಡ್ ಮಾಡ್ತೀನಿ ನಾನು. I will write the Vy in terms of V. So V value ಏನು ಬೇಕಿನ V sin theta into B. So this is the value of Fy. Clear? Okay. So now the charge particle, is it experiencing the magnetic force or not? Yes sir, it is experiencing the magnetic force. Due to which it is experiencing the magnetic force? Due to the Vy, it is experiencing the magnetic force. So because of the Vy component, the charge particle want to move in a circular path. It want to move in a circular path. But because of this one, so there is no magnetic force due to the horizontal component of velocity. Hangare, e velocity inda it is trying to move in a straight line path. So due to this velocity, it is trying to move in a circular path. ಯಾವ್ದು ಮೂವ್ ಆಗಬೇಕ್ರಿ Vx ಇರೋದ್ರಿಂದ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಹೋಗ್ಲಾಕ ಟ್ರೈ ಮಾಡಲಾತದ Vy ದಿಂದ ಹಿಂಗ ರೋಲ್ ಆಗ್ಲಾಕ ಸಾರಿ ರಿವಾಲ್ವ್ ಆಗ್ಲಾಕ ಟ್ರೈ ಮಾಡಲಾತದ ಬಟ್ ಎರಡು ಅಟ್ ಅ ಟೈಮ್ ಆಕ್ಟ್ ಆಗ್ಲಾತವ ಇವಾಗ ಅಸ್ಯೂಮ್ ಮಾಡ್ರಿ Vy ಕಾಂಪೋನೆಂಟ್ ಇಂದ ಹಿಂಗೆ Vy ಕಾಂಪೋನೆಂಟ್ ಇಂದ ಹಿಂಗೆ Vx ಕಾಂಪೋನೆಂಟ್ ಇಂದ ಹಿಂಗೆ ಇವೆರಡು ಕೂಡಿಸಿದ್ರೆ ಸಾರಿ Vx ಕಾಂಪೋನೆಂಟ್ ಇಂದ ಲೀನಿಯರ್ ಯಾಕೆ Vx ಕಾಂಪೋನೆಂಟ್ ಇಂದ ಲೀನಿಯರ್ ಬಿಕಾಸ್ Vx and magnetic field are in the same direction no magnetic force by the Vx it is trying to move in a straight line Vy is a result for the magnetic force, so due to that it is trying to move in a circular path. By the combination of these two, so it start to move like this. See here, it wanted to move in a circular path, but because of Vx, it travels further. It tried to move in a circular path because of Vx, it will move like this. So the path become like this. Okay, so E motion agla reason yaru Vx. ಈ ತರ circular motion agla reason yaru ಇಲ್ಲಿ ಹಿಂಗಾಗಲಿಕ್ಕೆ ಇದು, so this is Vy. ಗೊತ್ತಾಯ್ತಾ ಸೊ because of Vy it is in circular path, because of Vx it is in linear path. As a result of circular and linear, it covers or it follow a new path which is called helical path, okay. You may get a question, was the trajectory of the moving charge in an uniform magnetic field at an angle other than 0, 90, 180? So what is the answer? So answer must be it follows helical path. Gottagtala? Okay. So again we have to study the time period, frequency and radius of that moving charge in a helical path. ಈ ಮೂವ್ ಆಗತ್ತದಲ್ಲ ಎಷ್ಟು ಸರ್ಕಲ್ ಕವರ್ ಮಾಡತ್ತದ ಇದು ರೇಡಿಯಸ್ ನೋಡಬೇಕಲ್ಲ ಇಲ್ಲಿ ದಿಸ್ ಆರ್ ರೇಡಿಯಸ್ ಓಕೆ ಸೊ ರೇಡಿಯಸ್ ಇದ್ದರೆ ಹೌ ಮಚ್ ಟೈಮ್ ಇಟ್ ಟೇಕ್ಸ್ ಟು ಕಂಪ್ಲೀಟ್ one helix ತೊಗೊಳಾಕ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳ್ಳೋದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಓಕೆ ಸೊ ಆಕ್ಚುಲಿ ಬೇಸಿಕ್ ಫಾರ್ಮುಲಾ r = ಇಲ್ಲಿ ನಮ್ಮಲ್ಲಿ mv / qb ಹಾಗೆ ಈ ಕ್ವೆಶ್ಚನ್ ಬರೆದಿದ್ದೆ ಅಲ್ಲಿ ಏನಾಗಿತ್ತು the entire velocity was responsible for that circular path. ಇಲ್ಲಿ ಕಂಪ್ಲೀಟ್ v ಅದಕ್ಕೆ ರೆಸ್ಪಾನ್ಸಿಬಲ್ ಅದ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ನೋಡಿ ಹಿಂಗೆ ಆಗಿರ್ತದ ಇದು ಹೋಗೋದ್ರಿಂದ ಹಿಂಗೆ ಇಟ್ ಕವರ್ಸ್ ಲೈಕ್ ದಿಸ್ ಹೌದಾ ಓಕೆ ಸೊ ಇವಾಗ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಆಗಲಿಕ್ಕೆ ಕಂಪ್ಲೀಟ್ v ವೆಕ್ಟರ್ ಕಾರಣ ಅದೇನೋ ಇಲ್ಲ vy ವೆಕ್ಟರ್ ಮಾತ್ರ ರೀಸನ್ ಅದ vy ವೆಕ್ಟರ್ ಇಂದ ಈ ಸರ್ಕ್ಯುಲರ್ ಪಾತ್ ಹೋಗಕ್ಕೆ ಟ್ರೈ ಮಾಡತೈತಿ vx ವೆಕ್ಟರ್ ಇಂದ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಹೋಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡತೈತಿ ಹಂಗಾರೆ ರೇಡಿಯಸ್ ಯಾವ್ದು ರಿಸಲ್ಟ್ ಟೋಟಲ್ v ರಿಸಲ್ಟ್ ಏನೋ ಅಲ್ಲ ಮತ್ತು vx ರಿಸಲ್ಟ್ ಏನು ಅದು ಅಲ್ಲ ಇಲ್ಲಿ ಯಾವುದು ರಿಸಲ್ಟ್ ಇಲ್ಲ ಇಟ್ ಇಸ್ ಬೈ ದ vy only so I will write this as instead of v I will change it to vy okay what the value of vy so m as it is vy value no v sin theta divided by qb okay next time period ಏನಾಗ್ತದೆ ಹೇಳ್ತೀರಿ ಇವಾಗ nothing change because time period is independent of velocity ಹೆಚ್ಚಾದಾಗಲಿ ಕಡಿಮೆ ಆಗಲಿ ಅದು ಯಾವುದಾದ್ರು ಓರಿಯಂಟೇಷನ್ ಇರಲಿ ಸೊ ಇಫ್ ಇಟ್ ಈಸ್ ಅದರ್ ದನ್ 0 90 or 180 So it will be in a helical path. So the time period will be like a
Time period.
so time period will be same here. So independent of velocity, this is 2 pi m divided by qb. So frequency is reverse of this one, qb divided by 2 pi m. Okay, and what about the frequency? Frequency is qb divided by m. So frequency, angular frequency, time period. So the independent velocity, even though the velocity term change, they remain same. But here only Vy component. So these are the important equations related to motion of charge particle in presence of uniform magnetic field. So this is start. Thank you.